Okay, so a sequence is arithmetic if there is a constant d for which a sub n is equal to a sub n minus 1 plus d. The constant d represents the common difference of the sequence. And this is just a fancy mathematical way of saying that when you go from term to term, you are going up or down the same number. It's a constant difference. So common difference, but constant difference, meaning it's the same number every time. So you can tell if it's an arithmetic sequence by relating the terms to each other and seeing if the difference between the first and the second term is the same as the difference between the second and third, is the same as the difference between the third and the fourth. So if we look at this one, the difference here between 1 and 3 is 2. And the difference between 3 and 5 is 2. And the difference between 5 and 7 is 2. And the difference between 7 and 9 is 2. And so that is a common difference. The difference between each of these terms is 2. And so this is arithmetic. And our common difference, or D, is 2. If you look at the second sequence, the difference between 1 and 2 is 1, and the difference between 2 and 4 is 2, and then between 4 and 7 is 3. This is not a common difference. It's not the same. And so this is not an arithmetic sequence. And we don't have to name a common difference because it's not arithmetic. All right, and the third one, the difference between 20 and 12, we're going down 8 units, so that's a -8 difference. And between 12 and 4, again, we have moved down 8 units. Between 4 and -4, we've moved down 8 units. And between -4 and -12, we've moved down 8 units. And so that is a common difference. Your D common difference is -8, and that means that this is arithmetic. Now, this is a recursive formula, meaning that we have to use the term directly in front of us to get our current term. We have to go from 1 to 3, and we have to use 1 to get to 3. And to get to 5, we have to use 3. We have to add 2 to the term directly in front of the one we're looking for. But you can use an explicit formula for these sequences as well, and that explicit formula is right here. All right, and so this says a sub n, which is the term you're looking for, is equal to the first term plus the common difference times the term number minus 1. And so all you have to do is find these pieces and plug them in, and you have your formula that you need. So if we're looking at number 4, it says find the 102nd term of the sequence that they've given us right here. Well, in order to find the 102nd term, I need the explicit formula so that I don't have to find 101 terms leading up to it. So I need my first term. And so for this sequence, my first term is 5. They gave it to me. It's right there. That's our first term. And then I need my common difference. A sub n and n are going to stay, but I need my common difference. And so when I look at these, I see the difference between 5 and 13 is 8. And the difference between 13 and 21 is 8. And between 21 and 29 is 8. And 29 and 37 is 8. So my common difference is 8. And so we can write our formula a sub n equals my first term, which in this case is 5, plus my common difference, which is 8, times n minus 1. And a sub n stays there because that's the term we're looking for. So that's always going to be something we're looking for. And n stays there because that's the location of that term. So those two variables stay in our equation. Now, this equation should look kind of similar to you because you have seen it before with different variables. This is a linear equation, right? And usually we have a y here and an x here. But arithmetic sequences are linear relationships where you can establish that there is a slope, okay? And then you can find the terms in the sequence. In this case, like I said, you're used to seeing this with a y where the a sub n is and an x here. But in this case, when you're looking at this 8 right here, it's our common difference. But if we're talking about functions, we call that number slope. That's the slope. And you guys should notice that when we're looking at lists of numbers like we did in 1 through 3, the difference between 1 and 3 is 2. 3 and 5 is 2. That's our slope, right? We have a slope of -8 here. And here we have a slope of +8. Now, I can use this formula to find the 102nd term. A sub 102 is equal to 5 plus 8 times 102 minus 1. So that's 5 plus 8 times 101. And that's 5 plus 808, which is 813. All right, in number 5, they have given us an arithmetic sequence with a 5th term of 24 and a 9th term of 40. And they want us to find an explicit formula for the general term of the sequence. So they want us to write this equation right here, okay? And so, again, 5th term of 24 and 9th term of 40. We need to write the formula, we need the first term, and we also need our common difference. Those are the two things we have to find. So the easiest thing to find is our difference, because we talked about how the difference was the slope. And so if you have two terms, you can find me the slope, right? If I know that a sub 5 is 24 and a sub 9 is 40, we can say 40 minus 24, right? The distance between those two, divided by 9 minus 5, their number in line. So we went from 24 to 40, and we went from 24 to 40 in 4 jumps, right, between 9 and 5. And so this is 16 over 4, which is just 4. And that's our common difference. From term 5, we go up 4 to term 6, which is 28. And so if a sub 5 is 24, a sub 6 is 28, a sub 7 is 32, a sub 8 is 36, and a sub 9 is 40. Now, you can sort of mathematically reason around that as well. If you can look at those terms and say, okay, how do I get from the 5th term to the 9th term, 5th term of 24 to 9th term of 40? If you can do that without doing the slope calculation, that's fine. But you can do it using this calculation right here. Now, that gives me my common difference. My d is 4, and that's part of the formula. But I also need to find my first term. And so again, there are two ways to do this. You can use an equation. So I can plug in all my numbers to this equation and solve for a sub 1. Or we can count backwards. My guess is that you guys probably would prefer to count backwards. So we're going to do that. Do that here. So if a sub 5 is 24, a sub 4 with a common difference of 4 would be 20. 20 sub 4 is 24. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a common difference of 4 would be 20. 20 sub 4 with a a sub 3 would be 16. A sub 2 would be 12. And a sub 1 would be 8. And so that's our first term right there. So now I have my common difference in my first term, and I can write the formula for this, okay? And so we just plug in the numbers to this formula up here. I'll do that here. A sub n is equal to 8 plus 4 times n minus 1. And that's the formula. Just plugging in your first term and your common difference. That's the formula right there. All right, geometric sequences. Geometric sequences are sequences that have a constant multiplier. All right, so a sequence is geometric if there is a constant r for which a sub n is equal to a sub n minus 1 times r. The constant r is called the common ratio of the sequence, and it's a common multiplier. Like we are multiplying by the same number to move from one term to the next. So they want us, these are both geometric sequences, and they want us to determine what the common ratio is, so the number that we're going to multiply by to move from one term to the next. So from 4 to 8, we could say you're adding 4, but since I know this is a geometric sequence, I'm looking for a multiplier. 4 to 8 is times 2. We multiply 4 by 2 to get to 8. And then 8 to 16, that's another times 2. 16 to 32 times 2, and 32 to 64 is times 2. We multiply 4 by 2 to get to 8, 8 by 2 to get to 16, 16 by 2 to get to 32, and 32 by 2 to get to 64. So the common ratio for these sequences, for this sequence, is 2, right here. Just what did I multiply by to get from one term to the next? Here, it's a little trickier. I know that my ratio is negative. Why do I know that? Not because it goes in fractions, but because we go from a positive number to a negative number to a positive number, to a negative number, to a positive number. The next number is going to be negative. So I know it's negative, so I'm just going to start with a negative sign, like just write a negative. And then, how did I get from 1 to negative 2/3? What did I multiply by 1 to get to negative 2/3? And the answer is negative 2/3. And we can check that and say, okay, well, what happens if I multiply by negative 2/3 again? So multiply negative 2/3, which is this term right here, by my negative 2/3. And what you get is negative and negative make a positive. 2 times 2 is 4, and 3 times 3 is 9. And so that's my ratio right there. So like, that's my ratio, is negative 2/3. Multiply 4 over 9 by negative 2/3, you get negative 8 over 27, right? 4 times 2 is 8, 9 times 3 is 27. Multiply negative 8 over 27 by negative 2/3, you get 8 times 2 is 16, and 27 times 3 is 81. So our ratio here is negative 2/3. And the last thing we're asked to do is come up with a geometric formula. So this again is a recursive formula where we need the previous term in order to come up with the term we're looking for. But you can define these geometric sequences explicitly using this formula right here. A sub n equals a sub 1 times r to the n minus 1. Again, the things we would be filling in are the a sub 1, the first term, and then the common ratio, the r. A sub n and n minus 1 are the variables that stay. So if I have this sequence right here, what I need to find is a sub 1, which I have because they gave it to me. It's 4. It's just right there. And I need r. And so we look at the sequence and we say, okay, 4 times what gives you 20? Like, what times 4 gives us 20? And the answer is 5. And then we say, okay, well, 20 times what gives me 100? The answer is 5. And 100 to 500, again, is 5. And so we've established that that is a common ratio. This is a geometric sequence, and that's a common ratio. So r is 5. And our formula for this would just be a sub n equals 4 times 5 to the n minus 1. Now, this is your answer. That's your answer. Resist the urge to multiply the 4 and the 5. That is wrong. 5 has an exponent of n minus 1. I cannot combine it with anything else because I don't know what that exponent is. It's a variable. So the formula you're using is 4 times 5 to the n minus 1. You plug in an n value and evaluate the exponent and then multiply that by 4. You do not multiply the 4 and the 5 first. Do not multiply the 4 and the 5. This is not 20 to the n minus 1. That is wrong. Okay? Let's just make sure that we write that. So like 20 to the n minus 1, that is no bad. Okay? That is no bad. All right, leave it like this. Okay, and then just to make sure we're clear, guys, geometric sequences have to have a common ratio. They must have a common ratio. And so both of these, all three of these, had common ratios. But if you start looking at a sequence and you do not see a common multiplier like we found here, then it is not geometric. Okay, if they ask you, is this geometric, and you can't find the common ratio, it's not, you just say not geometric and move on. Sort of like we did with number 2 in the arithmetic, okay, because we couldn't find a common difference. All right.